Okay, let's dive right into this explainer. Today we are looking at a phenomenon we all experience literally every single day, but we rarely stop to think about. We're talking about how the apps on your smartphone seemingly magically adapt to your surroundings and the incredible invisible architecture of conceptual models that makes all of that happen. Think about the apps you use constantly. Your mapping software routing you around a sudden traffic jam, your weather app knowing exactly when it's going to rain right in your specific neighborhood, or a food delivery service pulling up the absolute closest restaurants to your location. Well, this explainer is going to show you exactly how that magic is engineered.
To really wrap our heads around this, I want you to picture a specific scenario. Imagine you're standing in a super bustling, crowded train station in Lille, France. You're a nomadic traveler, you're navigating a completely new city, you are completely exhausted, and you're just staring down at your phone. And you're probably wondering, with a healthy bit of frustration, why your transit app doesn't just automatically show you the local train schedules. Like, why do you have to manually type in your location, search for the specific station, and filter the results yourself? Why doesn't the app just know where you are and what you need in that chaotic moment?
Well, it all boils down to one fundamental difference: the difference between a rigid application and a context-aware application. You see, a completely rigid app is static. It forces you to dig through the exact same menus whether you're sitting comfortably on your couch at home or sprinting through a massive foreign transit terminal. It doesn't care about your reality, which, let's be honest, makes for a pretty terrible user experience. But on the flip side, a context-aware app is dynamic. It adapts its interface, its features, and its information based on your real-time situation. It literally molds itself to fit your immediate physical world.
So what do we actually mean when we say context in software design? Researcher Anand Dey hits the nail on the head. He defines context as any information that can be used to characterize the situation of an entity. That entity could be a person, a place, or an object, basically anything relevant to the interaction between a user and an application. And here is what's absolutely vital to remember. Context is not just your GPS location. No way. It's the time of the day, it's the specific device you're currently holding in your hand, it's your social role at that given moment, and it is the physical environment all around you.
Now you might be wondering, how on earth did developers actually build these incredibly smart, adaptable apps without going absolutely crazy programming infinite, highly specific scenarios? Well, they use a brilliant approach called model-driven engineering, or MDE for short. Think of MDE kind of like giving a business expert or a domain specialist a clear architectural blueprint to work with, rather than asking them to go out back, mix concrete, and build a house brick by brick. So instead of writing raw lines of complex code, developers are building applications using conceptual models that visually represent different parts of the entire system.
Moving on to Section 1. Meet Percomome.
Now, what's really fascinating about this next framework is how it solves the absolute nightmare of trying to hard code every single possible context scenario into an app. It's a method developed by researchers called PERCOM that stands for Personalization and Conceptual Modeling Method. And PERCOM is brilliant because it takes this highly complex, daunting 14-model system and organizes it into 5 really neat logical categories. You've got cross models, social models, environmental models, behavioral models, and interaction models. By separating these out, it becomes an absolute game changer for business experts. These are the folks who deeply understand the real-world needs of the user, but they probably aren't software engineers. And honestly, they shouldn't have to be. This logical structure allows them to piece together an application's logic conceptually, guiding the development without ever having to touch the final code.
Okay, Section 2. The brains. Rules and restrictions.
Let's move to how these models actually make those real-time decisions on your phone. This is where the system really gets its brains, using what developers call restrictions. A restriction essentially acts as a digital switch. Imagine a rule titled "User is in Paris." When you open your app, this restriction evaluates your user profile's current location against a vast geographic database, or ontology, and it simply returns a true or false. Yes, the user is in Paris, or no, they are not. It's a tiny, elegant piece of logic, but it's incredibly powerful because evaluating that one simple restriction can trigger massive, sweeping changes in what the app does next.
And this perfectly illustrates how we can trigger specific app behaviors based on 3 very specific types of restrictions used in this framework. First, we have application restrictions, like what kind of app are you actually using? Second, geographical restrictions, where physically are you standing right now? And third, time restrictions, what time of day or even what season of the year is it? Why does this matter? Well, by layering these 3 simple true or false switches on top of each other, the app starts to paint a surprisingly accurate and nuanced picture of your current, real-world reality.
Section 3. Modifying the app. The decision tree. But hey, the digital world moves incredibly fast. What happens when a transport company wants to update an app with a brand new context-aware feature? Say they want to add a special notification for train delays, but they only want it to show up for morning commuters. If you just shove new code directly into a live app, you risk breaking the whole shebang. So to manage this smoothly, developers use a highly structured decision tree. Step 1, they ask, does this modification change the user interface, the UI? Step 2, if yes, is it compatible with all the existing business processes already running in the background? Step 3, depending on those answers, they know exactly which conceptual model to modify, whether they're just tweaking a static visual model or if they actually need to build an entirely new background business process from scratch. It keeps everything super safe and organized.
Let's look at a real-world application of this from the Viatique.mobility project in France. Developers wanted to show a transport delay menu option, but they definitely didn't want to clutter up the user's screen all day long when it just wasn't relevant. So, using that decision tree, they applied an is-morning time restriction directly to the static interaction model. Now, that specific delay menu option simply evaluates the time of day in the background and seamlessly appears only during the morning rush. The UI updates itself flawlessly without the user ever lifting a finger.
Now, alternatively, sometimes the core business process itself needs to adapt, not just the visuals on your screen. Let's say you're printing an e-receipt. The app can evaluate an application restriction to determine what kind of app you're currently in. If it's a transit app, the business process triggers an action_transport receipt to print a ticket with specific travel terms. But if it's a completely different app, it triggers an action_service receipt for a generic format. The backend perfectly adapts to the context. That's a huge relief for developers because it means they don't have to rewrite the entire payment system just to print a slightly different ticket format.
All right, moving to Section 4, the Lille case study. Let's bring this all together and see how this builds a completely seamless experience for our nomadic traveler that we left standing frustrated back in the station in Lille. Because of geographic restrictions, the very moment our traveler opens the app in Lille, it automatically molds to the environment. It offers highly localized services, it gives them the option to buy merchandise and pick it up right at a specific corner of the Lille train station, plus the app knows to rotate localized advertisements on the screen every 20 seconds. But, and here's the really incredible part, if that exact same user takes a train and opens the app later in London, the geographic restriction instantly switches. The local merchandise option completely disappears, and the ads visually slow down, rotating only every 60 seconds. The app entirely reinvented itself based on a simple change in the user's coordinates.
And finally, Section 5, the future of context.
As we look toward the future of software modeling, managing all these shifting contexts presents a massive new challenge for developers. It is not just about the code anymore, it's heavily about human psychology. Researchers are now actively studying how context representations actually influence our cognitive control states. In fact, studies have put users through 96 intensive trials just to understand how human beings process these constantly adapting interfaces. Think about it for a second. Have you ever opened an app you use every day, only to find the layout has completely changed without any warning? It's incredibly frustrating, right? Well, that is cognitive overload. If an app changes too much or too unexpectedly based on context, it can actually overload a user's cognitive capacity, making the app way harder to use, not easier. Which brings us to the final hurdle in this field: managing uncertainty. The ultimate goal of model-driven engineering isn't just to make apps that change automatically. It's to manage the inherent uncertainty in those changes to increase usability and, most importantly, user trust. This is absolutely crucial. If your phone app thinks you're driving a car when you're actually sitting safely on a high-speed train and it locks your screen to prevent distracted driving, it immediately breaks your trust in that system. The conceptual models have to be flawlessly accurate to avoid causing that kind of real-world confusion.
So, I'll leave you with this provocative thought to end our explainer today. If the digital blueprints we use to build software already deeply understand our geography, our local time, and even the exact type of device we are holding in our hands, what incredibly complex human behaviors, subtle emotions, or social dynamics will they learn to adapt to next? The context-aware revolution is really just getting started.